Okay, last one. And the reason that we're covering pH. We're covering pH so we can cover this specifically. It's not a difficult concept, but it's a concept people struggle with. It's on the NCLEX. You have to know it. We have to figure this out. It's really not that hard, but for whatever reason, just people are weirded out by it. So stay with me. I promise you it's going to be worth it if you can make it to the end. This shouldn't be a long video. Respiratory acidosis. This is why we're studying pH, people. Here's what happens. It's caused by a decrease in respiration. So you cannot respire. You cannot get your CO2 out. You, in some cases, for whatever reason, you can't breathe out. It mostly happens in COPD, where your alveoli cells, the elastic in the alveoli cells, because of smoking, will let you breathe in, but the elastic doesn't snap back, so you can't breathe back out. So if you know people who are chronic smokers and they have some of those problems, they can breathe in, but they can't get the CO2 out. So their alveoli cells can expand, but they can't contract back again. So what happens? Here's what happens. You get an increase in CO2. So you've decreased respiration. When you decrease respiration, you increase CO2. This is very logical, right? I'm not breathing, so CO2 is not coming out of my lungs. When I do that, I basically mess with the pH, in which case it lowers the pH and makes it more acidic. So low pH, remember 1, 2, 3, 4, 5, 6, acid. So when I can't breathe out, I increase CO2, I decrease my pH. It's really not that hard, but people struggle. Okay, so there's also metabolic acidosis. So in some cases, you have other parts of your body, like your kidneys or your heart or other things happening that are adding acid, adding hydrogen ions everywhere, trying to donate protons everywhere, and they are lowering the pH of your body. So you have all this acid everywhere. Sometimes it's metabolic, sometimes it's respiratory. If someone comes in and presents with they can't breathe out, guess is it's probably respiratory. But very often what happens is they may have metabolic acidosis and it's presenting as some kind of respiratory issue because they're trying desperately, they're trying to get as much CO2 out because it's building up in their lungs and they're trying to get it out. And in reality, it's the metabolic that's causing the respiratory. So there's two ways that can happen. Buffers in the body. Increased breathing, again, can remove too much CO2 from the blood, causing respiratory alkalosis. So you can be too acidic or you can be too alkaline. So this is increased breathing. You are tachycardia, hyperventilation. You've experienced this. You hyperventilate before whatever, and you pass out so your body can get a handle on it because and too much CO2 is coming out, and it's messing with your pH. Your body's like, stop breathing, stop it. But some people, for whatever reason, they're anxious, something is happening in their life, and they can't stop. So what do? When people are hyperventilating, you put a bag over their head. What does that do? Think about what that does to my CO2. Then you have to breathe that CO2 back in, and it restores the pH balance. That's why you give people a bag to breathe in, because it forces them to breathe that CO2 back in, and it restores pH balance. Sound crazy, but that's exactly what you're doing. So let's go through that one. You are increasing your respiration. When you do that, you decrease your CO2 and you increase your pH. Respiratory alkalosis. And you can get these from blood samples, which you will immediately do when someone comes in and they're acting crazy. Okay, so let's do it again. Decrease in respiration, right? I cannot breathe out. What does that cause? I can't breathe out. Oh my gosh, the CO2 is building up in my lungs. I have all the CO2. What is the CO2 going to do? It's going to make bicarb, and that bicarb is going to decrease my pH. Respiratory alkalosis. Opposite. Now I'm too alkaline. Now I'm getting all the CO2 out because I'm hyperventilating or whatever. I'm on an airplane. I don't even know. All of it's coming out. Whoa, stop. Put a paper bag over them. Breathe the CO2 back in. Or, I mean, sometimes you can't. There's other things that have to be done. But I'm increasing my respiration. I'm decreasing my CO2. The CO2 is way lower than it's supposed to be. And that increases the pH, making it basic. Do you see how that works? Here is my little teeter-totter. We're going to have one in lab, and we're going to do this until you completely understand it, because this is the thing that the nursing program says everybody needs to know. And you just need to know in general. Even if you're not going to be a nurse, you still need to know this because it's important. When your respiration decreases, because why? You can't breathe out properly. Your respiration decreases, your CO2 increases. It's inversely proportional. If you can't breathe out, you get a buildup of CO2. Respiration and CO2 are the teeter-totter. Respiration is the same with pH. When your respiration is low, your pH is low. But respiration and CO2, if you just think about it logically, it makes sense. We can do the same thing if we put respiration over here. When our respiration rate is incredibly high, our CO2 rate is low because we're breathing it all out, but our pH increases with our respiration. I hope this has helped. We will do a bunch of these sort of problems, and we'll have a little teeter-totters, and we'll talk about it more in lab. But I wanted to get the 35 minutes just done so you have it in your notes so we can just jump in to doing some pH problems. Okay, see you in lab.